In this video, we will take a look at our septic example on our Objective 3 worksheet today. We are looking at using a limiting and excess reagent to determine the maximum yield of product that can form. We have just finished working our first example. Number 2 is very similar. I'll read it out loud. It says, bismuth 3 chloride and fluorine gas will react in the presence of extreme heat. Let's take a look at this single replacement reaction. If bismuth 3 chloride, bismuth who is a +3, the Roman numeral told me, reacts with chloride who's a -1. When I crisscross, I get BiCl3. It reacts with fluorine gas. Fluorine belongs to one of the lucky 7, so it's written as F2. Single replacement reactions follow the trend that say when a nonmetal reacts with a compound, it will kick out the nonmetal from that compound. In this term, it will be chloride. So now the bismuth hooks to fluoride. Bismuth, still a +3, hooking to fluoride with its charge of -1. The first product we can write, BiF3. And now that chlorine is written alone, chlorine also belongs to that lucky 7 diatomic molecule club, and so we will report that as Cl2. The skeleton shows BiCl3 reacting with F2 to form BiF3 and Cl2. This looks like it needs some help balancing. We've got 3's and 2's. I bet we'll need to turn them both into 6's, the lowest common denominator. If I begin by doubling the first reactant, 2 BiCl3's, that gives me a total of 6 chlorines and 2 bismuth. I'll fix the bismuth first by doubling that first product, 2 units of BiF3, repairing the chlorine then, 3 units of the Cl2 to give me 6, and then of course repairing the fluorine, there's a total of 6 on the right, we'll need a 3 there. So I have a 2 to 3 to 2 to 3 stoichiometric ratio. Reading through for letter B, how many molecules of chlorine, chlorine looks like our want, are produced when 195 grams of bismuth chloride reacts with 120 liters of fluorine gas. We are given information about both reactants. We know it's a limiting reagent problem. We will set up the first series starting with that 195 grams of bismuth chloride, BiCl3. I'll set up my 3-step parentheses so I can see my target. We want to know the chlorine, but notice that it asks me to get to molecules of chlorine. I'll write that target as MLC, standing for molecules of Cl2. The second reactant for fluorine gas was given to us in terms of volume. 120 liters of fluorine gas. I'll set those 3 parentheses ready. Those 3 parentheses still have the same target. We want to get to molecules of Cl2, the chlorine product. We'll begin with that first series of stoichiometric problems, the 195 bismuth chloride. I'll need to calculate a BiCl3 molar mass. Bismuth, I find that on the periodic table, he is number 83. 208.98, let's call that 209 for the bismuth molar mass, 209. I'll add 35.5 times 3 for the chlorine. I get 315.5 grams for our molar mass of BiCl3. In every 1 mole of BiCl3, bismuth chloride, it would have a molar mass of 315.5 grams. We're ready for the heart of our problem, the stoichiometric ratio, our want over given. We want to know the chlorine. Its coefficient of 3 stands for 3 moles of chlorine. Starting from our first reactant, 2 moles of bismuth chloride, BiCl3. In our third step, we want to count. We want to know the number of molecules. We know that there's an Avogadro's number, 6.02 times 10 to the 23rd, molecules of chlorine in every 1 mole of chlorine. When I use Avogadro's number, we get to the individual particles known as molecules. Let me hit this for us. I get 195, the initial weight of our bismuth chloride. I'll divide that by 315.5 times 3 divided by 2 times 6.02 second function, comma, that's my scientific notation e, to the 23rd power, and my screen reads 5.58 times 10 to the 23rd. My unit is molecules and the label chlorine. Knowing that I gotta get rid of this from up above, I'll just kind of separate on my particular worksheet the information from the above problem from the one that I'm working now. We have a second journey to take. Beginning with 120 liters of fluorine, we still have the same target, the product of molecules chlorine. Knowing in this first parenthesis, we are given a volume unit. The volume unit uses the molar volume of 22.4 liters for every 1 mole. The first parenthesis will use molar volume to cancel the liters we began with. In the heart of our problem, the stoichiometric ratio, we have a want over given. We see that our target is 3 moles of chlorine. Its coefficient of 3 will go on the top. We'll put that coefficient in front of the fluorine, who is also 3, on the bottom. Stoichiometric ratio is 3 over 3. 3 moles of chlorine set over 3 moles of fluorine. Same target, we will put 6.02 times 10 to the 23rd molecules of chlorine for every 1 mole of chlorine. Our divide, ratio, multiply. Where in the first step we use molar volume to cancel liters, and the last step we use Avogadro to go out to the world of counting particles. Let me hit for us 120 divided by 22.4 times 3 over 3 times Avogadro, 6.02 times 10 to the 23rd, using my E button, not times 10 and a caret key. When I hit enter, I get 3.2